This is part 2 of a 1 hour and 40-minute recorded Twitch stream from the 16th of April 2020, where we discuss the various MPLS VPN building blocks from a design perspective. In this session, we will cover Layer 1 to 3 design for core MPLS networks with a specific focus on key services and protocols, including physical design, loopbacks, IGP, LDP and BGP based VPN design. We hope you enjoy the video, and if you do, please let us know by providing a like, comment or telling anyone you know who may be interested. Thank you. Okay, so now that we have explained at a high level on a whiteboard, this is how it might be mocked up, if you like. And what we then move into is we start talking about how are we actually going to configure this. Let me move to the Visio diagrams. I'm just going to close the whiteboard session for now. But I'll just talk through this actually instead, and I'll talk through it on the presentation. So if we move into the next phase, we then start moving into the design of the MPLS network in like Microsoft Visio, OmniGraffle or whatever, and we typically work our way up from layer 1, then to layer 2, and then to layer 3. So the first thing with layer 1 connectivity is I've got everything here as a gigabit Ethernet port, but the reality of it is in a service provider network, not everything is going to be a gigabit Ethernet port. It's more likely to be 10, 40 or 100 gig Ethernet ports. But this diagram on the screen shows, you might draw this out initially on a whiteboard, but then once you get into the design documentation, you're probably going to be putting this into Visio, and you basically move through the layers. So layer 1, you see some things to call out here would be stuff like, on the on the PE, the interfaces here, you see this is a very small MPLS network. It's tiny in comparison. But the green nodes are the PE nodes, the purple nodes are the P nodes, the yellow node is the route reflector, and the blue is the customer edge node. And you'll see there's some like color coordination here. I like to do in my network diagrams to make things color coordinated, because for the person that's reviewing the document, or if somebody is troubleshooting the document, all they really need to do is look at the key in the top right hand corner of the diagram and say, mentally register that, right, because you might find that a P node in a larger network is in an obscure place. You might find that, for example, the purple node in this diagram might actually double up as a P/PE node and have sites connected to it. So you might actually just flag that as a PE node, even though its main functionality is label switching in the core. So that kind of covers an overview of the different components that, or main components. One thing that we didn't cover, and we're not going to cover in detail in this session, is there's another node referred to as an ASBR. So that's similar to an ASBR if you think in an OSPF network. It's a boundary router, but in OSPF, it's a boundary router where you might be doing redistribution from a different protocol or a different OSPF process. In an MPLS network, an ASBR is normally an inter-AS node. So if you've got BGP AS1, and let's say you were doing a merger with another internet service provider, and they were BGP AS55, but you didn't want to do confederations, and you didn't want to do you didn't want to renumber or use private AS or whatever when you're integrating the two networks, you would have an ASBR, which you could potentially join the two networks together and have a end-to-end label switching path. So the four nodes again in the MPLS core would be provider edge to provide segmentation and label switching towards the core. Then you've got the provider nodes, P nodes, which purely do label switching. Sorry, just to rewind a second actually, it's probably important to say what runs on what. So a provider edge runs like an IGP, OSPF, IS to IS, MPLS LDP typically, plus BGP VPN v4 and BGP IPv4 or 6, depending on what the services are that the customer is looking for. And the route reflector in the service provider core will run VPN v4 and VPN v6 typically. So it won't run, and plus OSPF and LDP. And I've actually, sorry, that might be a lot to take in, but I've got a slide after this one which shows the stack all together and what runs where. So if we move on to the next stage of a MPLS design, the next thing, after you do the physical connectivity, the next thing in the stack is going to be OSPF or IS to IS. And I would typically represent it something like you see on the screen. So you see here that you've got the MPLS core network, you've got the 4 PE nodes, you've got the 2 P nodes and the route reflector up the top. What we're representing here is all of those nodes come into the OSPF 100 area 0, one flat OSPF domain, and the reason for that is all we advertise into the IGP, OSPF or IS to IS is the loopback interfaces of these 6 nodes or 7 nodes, and that's to provide for LDP, which is the next level up, and we'll, again, as I say, we'll cover that in the next slide. So this is, you know, quite straightforward. You don't really get into. I've marked some example stuff down here, so I never managed to complete this diagram, but you'll see down on the right hand side I've started to populate the layer 3 information, and as you move through the design, you know, this is the typical format that I would use. So you see here that, you know, between this PE and CE, that's the customer PE to CE link. The subnet is 10.10.10/30. The customer is .2 and the provider is .1. Same thing for the secondary link, 10.10.10.4. And you try and get contiguous blocks if possible for this type of thing to make troubleshooting a bit easier. But then you move into the, you know, the link between the 2 PE nodes. Now this might not always be the case. It's just I've, you know, indicated that there's a link between the 2 PE nodes. There may or may not be that in place. It just depends on, you know, what you're trying to do and how big the network is and how critical the PE node is, etc. But it's the same sort of thing. Like, so 10.10.8/30.10 is, you know, PE4.9 is PE3, and then you would do similar sorts of things. You would move through the design, and this is the sort of thing that you would build out. We've still got the key in the top right hand corner, you see, which is, I like keeping this type of thing all the way throughout the design so it's consistent. So visually you can just look at the diagram, look at the key and determine what type of device is what. And then in the top left hand corner we have this probably isn't complete, but this might be, for example, if you're an architect or a designer and you're preparing this document for like a operations team or a project team. So anytime a P/PE node is configured or deployed in the network, this is the template that you use for OSPF and LDP in iOS XR or something like that. So I've only given a snapshot there, but it hopefully gives an indication of what, you know, a design could a design could look like. So going back to the question that was asked just before we had a problem with the stream was, is there no layer 2 design? So I've switched to Visio. We were talking about how in a MPLS core network we've got very limited functionality. So it's normally, the reason that you would use layer 2 is if, for example, you use the port channel. There might be, for example, multiple links which go between these core nodes in the P and the PE nodes. So you would port channel them together and either have a layer 3 or a layer 2 port channel, just depending on your environment and whatever you had available to you. But in the MPLS core, there's very little requirement for layer 2 from a label switching perspective. It's more, if you think about the stack, it's layer 1 physical connectivity, which is what we see on the first slide here. And this is sort of built out where, if you add another node, another P node, for example, let's say we needed additional redundancy, we would put that down here and then connect it up like that and sort of build it out. Maybe make both of these straight connectors. And then typically what you would do is just copy that and then change. You get the idea, and you're probably used to, you might or might not be used to doing it, but you would copy it and then you would change that. That might be gig 1/5. But the whole thing that I like about approaching things in Visio is to try and template things. So what I would do is I would create one purple router and then say, right, I need 5 P nodes in the network, so Control C, Control V 5 times, and then just get them like, I'll not do it here, but well, I'll not, paste what I need into the diagram and then move it about. So if this is if this network gets huge and it starts expanding, you move it out like this and configure it appropriately, and then you put the links between and you copy these, get these, interface numbers and things like that. And yeah, so the same would go for, let's say we need another 3 P nodes. We're building that out to upgrade the network, and then if we had another customer coming onto the network, we might just do it like that. And that's how I build things out from a speed perspective. Because one of the things I want to talk about in these sessions is not just, like, I'm not really here to teach you all the protocols under the sun, because there's loads of courses that can do that. What I'm trying to do is add value to you by giving you tips and tricks and maybe a little bit of knowledge on the way as to how the things work. But I'm not really going to deep dive on like all the protocols. It's more, how do you deliver a design for a L3 VPN network? So that's kind of how I would approach it. The question about, just going back to the question about layer 2, there's very small requirement for layer 2 in an MPLS core. There might be some thing, like if you've got actually services in the core, like, SIP trunking and things like that, and you've got limited devices, so you might need to utilize, I don't know, a port on a P node. I've seen and heard about designs, for example, that P nodes are meant to basically have IP addresses, an IGP like OSPF or IS to IS, and a label switching function on it. So that might be segment routing or LDP, and they're meant to do as little as possible. They're not there to process complex QoS policies. They're not there to segment traffic. That's inherent in the label switching, and the fact that it has no knowledge of customer routes. It's there to switch packets as fast as it can in the core of the network. So there's little layer 2 requirement. Where layer 2 actually might come into the mix is if, and we'll talk about this when we get into the configuration section, but if this customer has, let me change the colour. If this customer has, let's say they've got like, their data which goes and plumbs into their LAN. But they might also have something like a SIP service that comes in. So if they've got like a SIP service which comes from the provider, like let's say the SIP service is provided here in the service provider core, okay, and this is plumbed in somewhere like that, and it eventually ends up on this PE node. The service provider will probably hand that over on a separate VRF. So a single physical link, but a separate VRF on a sub interface, and then that'll land on like the customer's like session border controller or whatever. I'm drawn by hand instead, but that's a session border controller. So that's where layer 2, in my opinion, most of the time comes into the equation on a MPLS design. It comes if you're delivering a separate service, or the other way that, you know, that I've gave the example of SIP, but it could also be if you're delivering VLAN based versus port based layer 2 VPN. So if you're running VPLS, for example, and you've got 1 versus 2 VFIs and that are plumbed into the core. So the layer 2 design is more between the PE and the CE. Hopefully that answers the question. I'm sure there is there is times where you need to use it. You need to use it in the core, but you know, we're concentrating on MPLS VPN connectivity at the moment. So if we then move on to the next part of the diagram, okay. So what have we got so far? We've got the layer 1 physical connectivity, which is all like which port connects to which, and then we build out the network as required with extra physical appliances and things like that to be shown in the diagram. We've also got the layer 3 IP addressing. We've talked about layer 2, but that more comes at the edge. The layer 3 is IP addressing, so we're advertising loopbacks into OSPF in order for LDP tunnels to be created end to end, or label switch paths but end to end. We then move on to the next layer up, and in this slide, this box over here, yeah, layer 2 is more between the PE to the CE. So that would be to deliver services. As I say, unless you were delivering a pseudo wire or L2 VPN, but in order to deliver like a pseudo wire or an L2 VPN to do, you know, effectively make VLAN 10 available on the left and VLAN 10 available on the right, if that's what you want to do, that's not actually done by using like 802.1q trunks and VLANs in an MPLS network. How that's actually done in an MPLS network is you effectively nail up what we call a pseudo wire. You know, it might be here over the MPLS network, but that's done, you know, via L2 VPN configuration. It's not done by like going onto that port here and doing you know, instead of running MPLS LDP, and instead of doing that, it's not done by then just going and changing it to an 802.1q trunk. The 802.1q trunk might run here to here, and then you might have multiple VLANs which are allowed, but there's so many different topologies that you can implement. It just depends on the customer environment. We're kind of mainly concentrating on L3 VPN in this particular session, but we can talk about L2 VPN maybe in another follow-up. Let me just see and remove some of that ink. Eraser. Tidy up the diagram a bit. So the steps that we need to work through in order to build up and design an MPLS network are these here, right, and highlighted in this box. And step 1 consists of well, actually so this step here, configuring OSPF area 0. So if you think this represents a loopback interface on every one of these boxes. And the reason that as we mentioned earlier, that we need a loopback interface is because with LDP and label switching, we use loopback interfaces to peer between devices, and it's for if you don't know the reason for that, it's because if you peer on a physical interface and the physical interface goes down, then LDP will go down. So what we do is we create a loopback interface on the device in the global routing table, and then we advertise that into an IGP. In this case, we've got OSPF 100 area 0. So this whole core network, and this would typically be the same even if it was a bigger network. Everywhere in this blue line on the inside is process OSPF 1 area 0. We don't use multiple areas in OSPF typically, and if we there is ways to get around that, but the main reason for that is in order for a label switched tunnel or a label an LDP neighborship to form, it needs to be between /32, so host root addresses. So we create the loopback address, and then we add, and it's a /32. We advertise that into OSPF in the global routing table, and then we enable LDP, and we configure LDP to use that loopback interface as the router ID for LDP, and that means that the session is being established between loopback interfaces, similar to if you're using IBGP and you want to peer IBGP between loopback interfaces. So you see here in the stack, we configure the loopback interface, and then we configure LDP on top. Switch back to blue, but you get the idea. After this, the next thing in the stack is VPN v4 IBGP. So if you think of BGP, if you think of VPN v4 and VPN v6 IBGP, these again are all going to be contained to the inside of the network, but so I'll mark it out. It's going to be contained to the inside of the network, of the core network. However, the peering, the actual peering of VPN v4 and VPN v6 would have to either be, a full mesh. So, and you can imagine in a service provider network doing a full mesh between, every single router in the network. It's going to get a bit crazy. So instead of doing that, what we do is we peer to a VPN v4 route reflector or route reflectors, and that can be a VPN v4 route reflector on its own, or it could be a VPN v4 and a VPN v6 route reflector. It could also be a route reflector for other address families in BGP, but typically it's VPN v4 v6. Sometimes you might split these out, so you might have a VPN v4 and a VPN v6, and that's all around if you might have scaling limitations in the control plane, for example, where you don't want to mix VPN v4 and v6 and then max out the resources on a single box, or it might be a policy thing or whatever. So just recapping, it's create the loopbacks and the IPv4 interfaces. And we'll cover it in a second when we move into like the configuration part and that. Another point that I never really talked about so far is the MPLS core. So if you go back to this diagram, if you look at here, right, and you notice that, you know, this is our IPv4. If you had these links configured, these are all IPv4 as well. So even when you run IPv6 to the customer, let's say that this was a v6 peering, in the middle of the network, it's still going to be IPv4. And we'll talk about that when we get into the configuration part. So, we'll move back here. So we've got the loopbacks, the IGP, we've got the label switching, LDP is built on top. Then we start moving into BGP VPN V4 and V6, which peers internally to the, you know, where that thick blue outline is. And then we start moving on and concentrating on, you know, the provider edges. And this is where we start configuring like VRFs for different customers. Once we configure a VRF, we can then peer eBGP, so it's an external BGP over IPv4 unicast. So it's a different address family. So in the core of the MPLS network, we use VPN V4 and VPN V6 over an IPv4 routed network, and then between the PE and the CE we use external eBGP. We configure VRFs on the PE, and there may or may not be VRFs configured on the CE. So that's basically the MPLS stack and how it's designed and the order that it's designed in. And I think that to move to the next sort of stage in this is probably worth showing you a configuration and how this actually fits together. This concludes part 2 of MPLS VPN building blocks. Please click the link in the description for part 3, where we will take a deeper dive into core MPLS design scenarios using a small MPLS lab to provide explanation and validation of the design.